Hello everyone, my name is Kanika. In the previous slides, we discussed about few parts of data handling, that is different types of graphs. Then we discussed about the probability, and then we discussed about the measure of central tendency, that's mean, median, and mode. Now we will be continuing the probability further. Let me share the slides with you. So in these, we will be talking about theoretical versus experimental probability, and the most important part, cards, coins, and dice based problems. We have different types of cards as in playing cards. We have 52 cards that we will do in detail. And then for coins, when you toss a coin, one coin you toss, when you toss two coins simultaneously or three coins simultaneously, we will be learning those. Then the dice based problems means when you are rolling one die or two dice simultaneously. Let's understand. So first part is experimental versus theoretical probability. So theoretical probability is what we expect to happen, where experimental probability is what actually happens when we try it out. So basically, if we talk about theoretical probability, so theoretical probability is related to only one single trial. Now, we learned about the experiment in the previous presentations. So experiment is when you have multiple trials in it. So in case of these multiple trials, when we are talking about the whole experiment, then it is known as the theoretical probability. Sorry, this is experimental probability. I'm so sorry. This would be experimental probability. And if we talk about a single trial, then that is known as theoretical probability. Like for example, a coin is tossed 10 times, head is recorded 7 times, and tail is 3 times. So basically they are talking about an experiment because they have 10 trials in it. So probability of head would be 7 over 10 and probability of tail would be 3 over 10. And if we move to theoretical probability, if we talk about it, so theoretical probability is when the probability is related to a single trial. As in, you are tossing a coin, so probability of getting a head is 1 by 2 and probability of getting a tail is again 1 by 2. Formula remains the same, it's just that in case of experimental probability, you take experiment into account. And in case of theoretical probability, you take one trial into account. So let's look at the statements. As more trials are conducted, the experimental probability generally gets closer to the theoretical probability. All right, because it will give you more specific results. That is why when you have more number of trials in an experiment, then experimental probability will become more closer to the theoretical probability. Now let's move further. Let's look at a question. A bag contains 10 marbles, 8 blue marbles, and 2 yellow marbles. Now you have to find out the experimental probability of getting a blue marble. Read the question carefully. Experimental probability. So you have to assume that how many trials you are taking. Let's say you are taking 10 trials in an experiment. We are simply assuming it. All right. And if we talk about, let's say out of 10 trials, in 6 trials you are getting blue marble. So probability of getting a blue marble would be 6 over 10, which would be equal to 3 over 5. And this is the case of experimental probability. And if we talk about the theoretical probability, so probability of getting a blue marble is 8 over 20. That's 2 over 5. So these are not same. You have to check whether the question asks for experimental probability or theoretical probability, because usually students simply do this part, not this one. So that is why you have to read the question properly. That is important. Let's look at the solution given in the slide. So take a marble from the bag, record the color and return the marble, because they are not saying that you have to remove the marble and keep it aside. All right. So you have to return the marble again in the bag. Repeat a few times. Now you can take any number of your choice. So they have taken it as 10 and blue marble picked was 6. You can choose any number of your choice. That's purely up to you. So experimental probability of getting a blue marble would be 6 over 10. That's 3 over 5. I hope this part is clear, because reading question is important. All right. Let's move further. Find the probability of rolling an even number when you roll a die containing the number 1 to 6. Express the probability as a fraction, decimal, ratio, and percentage. Now, sample space is basically all the terms which are like, it's basically total number of terms. Sample space is 1, 2, 3, 4, 5, and 6. And if we talk about the favorable outcomes, so favorable outcomes are, we have to find out the even number. It would be 2, 4, and 6. So probability of getting an even number would be 3 over 6, which is equals to 1 by 2. So that is your fraction. Now, if you want to convert it into decimal, that would be 0.5. Ratio would be 1:2. And percentage would be 50%. Or you can simply find it out by multiplying it with 100. You will get 50% as the result. I hope the question is clear. Now let's look at the solution given. So as we discussed, the ratio, the probability was 1 by 2. Fraction is that's the fraction, and then decimal is 0.5. Ratio is 1:2 and percentage is 50%. Let's move further. Problem on coins. So coin will have always two outcomes. One is head, second is tail. Now, probability of event PE is equals to number of favorable outcomes divided by number of possible outcomes. That's the basic probability. So this was the case when only one coin was tossed. If we talk about two coins, so there will be 4 outcomes. That would be H on first coin and H on the second coin, tail and tail on both the coins, head on one and tail on one, and vice versa. So total number of possible outcomes are 4. Similarly, if we talk about 3 coins, so total number of outcomes are 8. So how will you judge whether how many possible outcomes are there? The formula is 2 raised to n, where n is given by number of coins tossed. So like in the second point, we were talking about 2 coins. So 2 square is the number of possible outcomes, that gives you 4. And if we talk about 3 coins, so 2 cube, that would be giving you 8. If we talk about 4 coins, so 2 raised to 4 would be 16, and so on. So if you are tossing 2 coins, 4 outcomes, 3 coins, 8 outcomes, 4 coins, 16 outcomes, and so on. So this is the basic formula of finding out number of possible outcomes. Where n should be an integer because it is number of coins. Let's look at the question to understand the concept better. 3 fair coins are tossed simultaneously. What is the probability of getting at least 2 tails? So 3 coins are tossed. That means sample space will have 8 possibilities. Let's form the possibility. So this would be head on all the coins, then head, head, tail. Then you have head, tail, tail. Then you have H, H, T, H, T, T. Then three tails, T, H, T, 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 H. And then you have T, H, H. And one more is left. It would be H, T, H. All right. So you have to find out the probability of getting at least two tails. So at least two tails means minimum should be two, maximum can be three as well. But two should be there. So probability of getting at least two tails would be first of all, the total outcomes are 8. Now let's look at the favorable ones. This would be 1, 2, 3, 4. So 4 possibilities are there. That's 1 by 2. Let's look at the solution. So as per the discussion, these are the favorable outcomes you have. These are the total outcomes you have. And the probability becomes 1 by 2. Let's move further. Now let's talk about the dice. So dice, when you have one single dice, there are 6 outcomes. 1, 2, 3, 4, 5, 6. And if we talk about 2, so you have 2 raised to the power 6. No, sorry. Sorry. This is not 2 raised to the power 6. The basic outcomes are 6. So it would be 6 raised to the power 2. Answer would be 36 outcomes. Like we did for the coins, base number was 2 and then you had to look for the power. Similarly, in case of dice, the base number would be 6 because the basic outcomes are 6 and then n. Now n represents number of dice rolled. Now let's look at the statement. 2 dice are rolled. Let A, B, C be the events of getting a sum of 2, sum of 3 and sum of 4 respectively. So this is event A, this is event B, this is event C. A is a simple event. Simple event means you have to simply get a sum of 2. B and C are compound events. If you are talking about this and this both, these are compound events because they are interrelated to each other. And if we talk about A and B, the sum of 2 and sum of 4, they are mutually exclusive events. Like you cannot have the numbers which are basically the sum is 2 and 4. That's practically not possible. Either you get the sum as 2, either you get a sum as sorry. This is A and B. I'm so sorry for this. A and B. So sum of 2 and sum of 3. One is even number and one is odd number. So even and odd number, obviously practically it's not possible. So that is why they do not have anything in common. Hence they are known as mutually exclusive events. Let's look at the solution. Now, for the first one, it was you have to check whether the first A is a simple event. So A is a simple event means the sum should be 2. There is only one possibility, 1 and 1. That's it. So that is why it is a simple event because it has only single sample point or single favorable outcome. Now let's talk about B and C. So sum should be 3 and sum should be 4. So for B, it is 1, 2 and 2, 1. 2 possibilities only. And for C, it would be 1, 3, 3, 1 and 2, 2. Sum would be 4 in these outcomes. So since they have more than one outcomes or more than one sample point, these are known as compound events. And now if we talk about A and B, so they do not have anything in common. This is basically the common part. A does not have anything in common. So A intersection B intersection means the common elements. It's 5. 5 means empty or null. So that is why they are mutually exclusive events, because they do not have anything in common. And these are your sample space values. Fine. Now let's move further. Two dice are thrown. Find the odds in favor of getting the sum 5 and odds against getting the sum 6. So you have to check like which numbers can get the sum as 5 and which numbers cannot get the number as 6, answer as 6. So let's look at the possibilities. S is the sample space. We know that there are 36 elements. So E1 be the event of getting the sum 5. This is because it was in favor. So possibilities are 1, 4, 2, 3, 3, 2 and 4, 1. So there are 4 possibilities. Probability would be 4 over 36, which is 1 over 9. So odds in favor of getting E1 would be 1 by 9 divided by 1 minus 1 by 9. So possible this would be reason being because you have to find out the odds in favor. So this is the favorable part, as in the total part, and then 1 minus 1 by 9 gives you answer as 1 by 8. And then if we talk about the odds against getting the sum 6, so it would be 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. Answer would be 5, and then this would be 5 over 36. You have to find it out in against. So against would be not E2. I told you in the previous slides that PE1 plus P not E is equals to 1. Sum of probabilities is always 1, right? So we have to find out odds against E2. So it would be 1 minus probability of E2. So it would be 1 minus 5 over 36 divided by total, and you get this as the answer. I hope the question is clear. Now let's move further. Now we will be talking about the cards. So cards, it has a total of 52, out of which it is divided into 4 suits, 13 cards each, that is spade, heart, diamond and club. So cards of spades and clubs are black, cards of hearts and diamonds are red. Each of them have ace, king, queen, jack, and then the numbered cards, out of which king, queen and jack are known as face cards. All right. So there are 12 face cards in total. That is 3 into 4 suits, you get 12. Let's understand them in the form of table. It would be easier to learn them then. All right. So we have spade and club. These are black colored cards. Diamonds and heart. These are red colored cards. So 1, king, queen, jack, ace, numbered cards. So total becomes 13 in all of them. Let's understand it by an example. Total is 52. You have to find out the probability of 2 of spades. So there is only 1 2 card in the spade, right? So this would be 1 over 52. And if we talk about a jack, jack could be from any of the 4 suits. So there are 4 jacks divided by the total. So you get the result as 1 over 13. That's the probability of getting a jack. Let's look at the solution. As we discussed, so 1 by 52 for getting 2 of spades and 1 by 13 as the probability of getting a jack out of total 52 cards. Next question. A card is drawn from a well shuffled pack of 52 cards. Find the probability that it's neither spade nor a jack. So in spade there are total 13 cards. And in Jack, there are total 4 cards, but one is already included in the spade. So we are left with 3 Jack cards. The total becomes 16. So neither spade nor Jack. So you have to get this 52 minus 16, or what you can do is you can simply find the probability of getting a spade or a Jack. So this would be 16 over 52, and you have to subtract it from 1, or you can simply subtract them and get the result. So 12 minus 6 would be 6, and then 4 minus 1 would be 3. 36 over 52, that would be equal to, let's cancel it out by 2. So this would be 18, and this would be 26. This would be 9, and this would be 13. So answer comes out to be 9 over 13. So this is how you have to do the question. There are two ways: either you calculate it by this way, or you calculate it by 1 minus 16 over 52. Because we have to calculate the value of P not E. That would be equal to 1 minus probability of event E. Next, let's look at the practice questions. The practice questions: bag contains 10 red marbles, 8 blue marbles, and 2 yellow marbles. Find the theoretical probability. Now again, it's the same question, but in this case, you have to find out the theoretical probability of getting a blue marble. So total are 20. Probability of a blue marble would be 8 over 20. That is equals to 2 over 5. So answer for the first one becomes 2 over 5. Then the second one, 2 fair coins are tossed simultaneously. What is the probability of getting only one head? Now let's form the sample space for it first of all. So this would be head, 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 tail, head, and then tail, tail. Now you have to find out the probability of getting only one head. So there are only two possibilities. So it would be 2 over 4, which is equals to 1 by 2. Next is, a card is drawn from a well shuffled pack of 52 cards. Find the probability of neither a heart nor a red king. Neither a heart. So 13 cards, which includes king. And then nor a red card. Red king. So red king means there is only one red king left because one is already included in the form of hearts. So now you have a total of 14 cards. Or you can, and we have to find out neither a heart nor a red king. So 52 minus 14. So that would be equal to 38 over 52. So this would be 19 over 26. That's your answer. Let's check them. Yeah. So all of them are correct for us. 2 by 5, 1 by 2, and 19 by 26. So with this, we completed the chapter, and I hope there is no doubt at all. All right. So I'll see you in the next session now. Okay, till then, take care. Bye-bye.